The universe has always been a place of profound mystery. For all of human history we have gazed up at the night sky, a vast dark canvas sprinkled with distant points of light. We told stories about those lights. We saw gods and heroes, monsters and myths. We wondered what they were and if we were alone in the vastness. For millennia those questions remained unanswered, whispered only in our imaginations. But we live in a remarkable age. Today we are no longer just telling stories. We are beginning to read the story the universe is telling us. It is a story written in starlight, in the faintest whispers of radiation, and in the gravity that binds everything together. And just when we think we understand a chapter, a new page turns. Something truly spectacular has just happened. It is a moment that will be remembered in the history of astronomy, a turning point in our quest to understand our place in the cosmos. The James Webb Space Telescope, our most powerful eye on the universe, has done something extraordinary. It has pierced the cosmic veil in a way no instrument has before. It has not just studied a distant world, it has found one. This isn't just another dot on a graph or a wobble in a star's light. This is different. This is a direct discovery, a photograph of a new planet in its infancy, a world we never knew existed until this moment. It reminds us that for all we have learned, the universe still holds breathtaking secrets, waiting patiently for us to build the tools to find them. The discovery feels like a scene from science fiction, but it is beautifully, wonderfully real. Imagine standing on a shoreline staring out at an endless ocean and suddenly, a new island emerges from the mist. That is what has happened out in the cosmos. For so long we have been limited in how we search for other worlds. We looked for shadows and gravitational tugs, indirect clues that told us a planet might be there. But now, with Webb, we have stepped into a new era. We can start to see these worlds for ourselves. This is not just an incremental step forward, it is a giant leap, fundamentally changing our relationship with the stars and the planets that may orbit them. The implications are staggering. Every new world we find is a new piece of the cosmic puzzle. It tells us more about how planetary systems form, how they evolve, and how common, or how rare, our own solar system might be. This single discovery opens a floodgate of possibilities. It proves that our technology has reached a level of sensitivity we once only dreamed of. The universe is speaking to us, showing us its hidden treasures. And with this new discovery, we are finally learning to listen, and to see, with a clarity that will reshape our understanding of everything. The great cosmic ocean is vast and we have just launched a new ship. We are ready to explore. Let's be clear about what has been achieved. The James Webb Space Telescope has directly imaged a previously unknown exoplanet. It is named TWA-7b. This is not a re-examination of a planet we already knew about. This is a genuine discovery. Webb pointed its golden eye towards a young star, and there, orbiting it, was a world no human had ever seen before. It is a moment of pure exploration, akin to the great explorers of old charting unknown lands for the first time. This isn't a statistical blip or a mathematical inference, it is a picture, faint but undeniable, of a planet in another solar system. It is a new member of the galactic family, and we are the first to say hello. This new world, TWA-7b, orbits a star about 110 light-years away from us. In cosmic terms, that is our neighbor. The star itself is a mere baby, only about 6 million years old. Our own sun, by comparison, is a middle-aged 4.6 billion years old. Because the system is so young, seeing a planet here is like looking back in time. We are witnessing the early chaotic days of a solar system's life. This is a priceless opportunity to see how planets form and settle into their orbits. It is a snapshot from the universe's family album, showing us what our own solar system might have looked like in its infancy. This isn't just astronomy, it is cosmic archaeology. The planet itself is a fascinating object. It is a gas giant, but a remarkably lightweight one. We can think of it as a cousin to Saturn in our own solar system, but it is less massive. It is not a rocky world like Earth or Mars. Instead, it is a huge ball of gas, likely hydrogen and helium, without a solid surface to stand on. Its existence challenges some of our ideas about planet formation. Finding a planet like this, so far from its star, and with such low mass, gives theorists new data to work with. Every discovery like this refines our models, helping us to build a more complete picture of the universe's creative processes. But what truly sets this discovery apart is the method. Webb found TWA-7b through direct imaging. This is the holy grail of exoplanet science. For decades, we have found thousands of planets using indirect methods, like the transit method, where we watch for a star's light to dim as a planet passes in front of it, or the radial velocity method, where we look for the gravitational wobble a planet induces in its star. These methods are brilliant, but they only tell us a planet is there. Direct imaging is different. It is seeing the planet itself, capturing the faint photons of light that have traveled across interstellar space from that world to Webb's mirror. It is a profound, almost personal connection to another world. Finding a planet next to its star is one of the hardest things to do in astronomy. The challenge is almost incomprehensible. A star is billions of times brighter than the planet orbiting it. Trying to see an exoplanet is like trying to spot a firefly sitting next to a searchlight from hundreds of miles away. The star's brilliant glare completely overwhelms the faint, reflected light of the planet. For years, this fundamental problem has hidden countless worlds from our view. Even the magnificent Hubble Space Telescope, for all its power, struggled with this. It could study some known bright exoplanets, but discovering new, faint ones so close to their stars was largely beyond its reach. This is where the genius of the James Webb Space Telescope comes in. Webb is equipped with a revolutionary piece of technology called a coronagraph. You can think of a coronagraph as a highly sophisticated hand you can place in front of your eyes to block out the sun. It is a tiny, precisely engineered mask inside the telescope that blocks the intense light from the central star. By canceling out that overwhelming glare, the coronagraph allows the incredibly faint light of an orbiting planet to become visible. It is an instrument of exquisite sensitivity, designed to reveal the ghosts hiding in the machine of a solar system. It is this technology that allowed Webb to see TWA-7b. The process is incredibly delicate. The telescope must hold perfectly still, and the coronagraph must be aligned with pinpoint accuracy. Any tiny error and the star's light would leak around the mask, ruining the observation. But Webb's engineering is flawless. When it stared at the star TWA-7, the coronagraph did its job perfectly. It suppressed the starlight, and out of the darkness, a tiny, faint speck of light appeared. This speck was TWA-7b. It was a technological triumph, a testament to the thousands of scientists and engineers who worked for decades to build a machine capable of such a feat. It has opened a new window on the universe, allowing us to see what was always there, but forever hidden from our view. This breakthrough means we can now start to search for planets in places we couldn't look before. Many planets, especially those in wide orbits far from their star, do not transit. They never pass in front of the star from our point of view. The indirect methods would miss them completely. Direct imaging with a coronagraph is the only way to find these worlds. TWA-7b is the first of what will surely be many such discoveries. Webb is now sweeping the skies, capable of finding these hidden planets. We are about to fill in the missing pages of our planetary census, revealing a population of worlds we never knew existed. The search has truly just begun. To understand TWA-7b, it helps to compare it to something familiar. Imagine Saturn, the jewel of our solar system, with its beautiful rings and gaseous nature. TWA-7b is a gas giant like Saturn, but it is different in some key ways. It is significantly less massive, a lightweight giant compared to our own. This makes its existence even more intriguing as it pushes the boundaries of how small a gas planet can be. But the most dramatic difference is its orbit. Our Earth orbits the Sun at a distance we call 1 astronomical unit, or AU. TWA-7b orbits its star at a staggering 52 AU. That is 52 times farther from its star than Earth is from the Sun, placing it far beyond where Pluto lies in our own system. This enormous distance from its parent star makes TWA-7b a cold and lonely world. From the upper layers of its atmosphere, its sun would appear as little more than an intensely bright star in the sky, not the life-giving disk we know. Its orbit is so vast that a single year on this planet, the time it takes to circle its star once, would last for centuries in Earth time. It lives in the cold, dark outer reaches of its solar system, a silent sentinel in a young and forming family of worlds. Its great distance is also one of the reasons Webb was able to see it. Being farther from the star makes it slightly easier to separate its faint light from the star's glare. What makes this system so scientifically precious is its age. At just 6 million years old, TWA-7 is a cosmic baby. Our solar system is like a fully grown adult. This one is a newborn. Seeing a planet like TWA-7b here is like having a time machine. We are witnessing a planetary system in the process of being born. Astronomers believe that planets form from a large disk of gas and dust that surrounds a young star, known as a protoplanetary disk. By studying TWA7b, we can test these theories directly. We are no longer just looking at computer models. We are looking at the real thing, a planet fresh from the cosmic nursery. This youthfulness provides us with a unique laboratory. We can study the planet's atmosphere to understand its composition, which can tell us about the materials that were present in the early days of its solar system. We can observe its orbit and its relationship with its star to understand the chaotic dance of gravity that shapes young systems. This discovery is not just about finding another planet. It is about understanding the fundamental process of creation that gives rise to all planets, including our own. It is a glimpse into our own distant past, written in the light of a world 110 light-years away. The story of TWA7b gets even more exciting. When Webb looked closely at this young planet, it saw more than just a simple ball of gas. The data suggests that TWA7b is surrounded by its own disk of dust and debris. This is called a circumplanetary disk. Think of it as a miniature version of the large disk that surrounded its star. Just as planets form from the disk around a star, moons can form from the disk around a giant planet. What Webb might be seeing is the very beginning of a lunar system. We could be witnessing for the first time the birth of exomoons. This is a profoundly beautiful idea. We are not just watching a planet, but a potential cradle of new worlds. Within that dusty ring, tiny grains of dust are likely colliding and sticking together, slowly growing into larger and larger objects. Over millions of years, these could become fully fledged moons, orbiting TWA7b just as our moon orbits the Earth. The discovery of this disk is almost as significant as the discovery of the planet itself. It provides the first observational evidence that moons might form in the same way as planets, a theory astronomers have long held but have never been able to see in action until now. The presence of this moon-forming disk fuels our imagination and builds a sense of incredible suspense. If we can see moons forming around this gas giant, what else is out there waiting to be discovered? Each new capability of Webb seems to unlock another layer of the universe's complexity and beauty. We started by finding planets, and now we are seeing the systems of moons that might accompany them. It makes the cosmos feel less empty, more dynamic, and filled with the same creative processes that shaped our own cosmic home. The universe, it seems, is constantly building, constantly creating, on scales both large and small. This discovery invites us to wonder about the sheer variety of worlds the galaxy must hold. We have found hot Jupiters, super-Earths, and now a lightweight gas giant with a moon-forming disk. It shows us that nature is far more imaginative than we are. For every type of planet we predict, the universe seems to show us 3 more that we never expected. This is what makes science so thrilling. It is a journey into the unknown, where every new observation has the potential to rewrite the textbooks. TWA7b and its dusty ring are a powerful reminder that we are just at the beginning of our quest to map the cosmos. There are so many more surprises out there. Naturally, a discovery like this leads to the ultimate question: could there be life on TWA7b? In this case, the answer is almost certainly no. As a gas giant with no solid surface and extremely cold temperatures due to its vast distance from its star, it is not a candidate for life as we know it. Its value is not in its habitability, but in what its discovery represents for the search for life elsewhere. This breakthrough is a crucial stepping stone. It proves that Webb's technology works. It proves that we can directly image planets. And if we can do it for a gas giant, then we are one step closer to doing it for a small, rocky world like our own. The discovery of TWA7b is a dress rehearsal for the main event. The ultimate goal for many astronomers is to take a direct image of an Earth-like planet orbiting a Sun-like star. We want to find a pale blue dot around another star. Once we can do that, Webb can do something even more extraordinary. It can analyze the light from that planet's atmosphere. By looking at the chemical fingerprints in the light, we could search for biosignatures, gases like oxygen, methane, and water vapor, that could indicate the presence of life. Webb's success with TWA7b tells us that this dream is moving from the realm of science fiction into the realm of possibility. This brings us to a truly spine-tingling thought. For the first time in human history, we have the technology in place that could, within our lifetimes, find evidence of life on another world. Think about that for a moment. All the generations that came before us could only wonder. We might be the generation that knows. The discovery of TWA7b is a signpost on that journey. a bright beacon of progress that tells us we are on the right path. The search will be long and difficult. Finding a small rocky planet is much harder than finding a large gas giant. But the path is now clear, the tools are in our hands. So as we look up at the night sky, it no longer feels quite so empty or silent. We know now that it is filled with countless worlds more varied and wonderful than we could have imagined. TWA-7b is just the latest to be revealed. It fuels our curiosity and our hope. It encourages us to keep looking, to keep exploring, and to keep asking the big questions. What else is out there? What other wonders are hiding in the glare of distant stars? And could the next great discovery, the one that changes everything, be just around the corner? The universe is waiting. And for the first time, we are truly ready to see what it has to show us.